This is the Centre for Sport and Exercise Science at Sheffield Hallam University. We're here to interview Simon Choppin, who is a sports engineer.
Okay, this is the Centre for Sports and Exercise Science. I'm a sports engineering researcher at the Sports Engineering Research Group. And that's really concerned with everything to do with sport and sports equipment, whether it be bikes that go faster, swimmers that can move through the water quicker, or balls that are more powerful. We use all types of techniques in order to investigate these different things. Okay, this is the BATAC Pro machine. This is used for athletes to train reaction times and develop the speed. It's particularly used by Formula 1 athletes because it's good for the periphery vision, for looking to the corners of where you can see, and also speeding up your reaction times in corners and things like this. So a timer starts, and you have to hit as many of these lit buttons as you can in 30 seconds. Now a good average score is around 30, but Formula 1 drivers have been known to score over 70. There's two scores that we can get from this piece of equipment. If we divide the number of hits by the time taken, then we get the average rate, so the number of buttons you hit per second. But we can also calculate how long it takes to hit each button, which is reaction time. And to do this, we take the time and divide that by the number of hits. High-speed video is used commonly to assess the performance of different pieces of equipment. Manufacturers might bring the tennis rackets or different pieces of sports equipment into us, and we can test how well it performs. For example, a manufacturer might be interested in how fast a ball leaves a racket after impact, and whether their new design improves upon old equipment. In order to do this, a tennis player is filmed hitting a ball, and the distance the ball travels in a particular time is measured. This distance divided by the time gives the speed of the ball. In this example, the video is recorded at 1,000 frames per second. This is 40 times quicker than standard video. To measure the distance that the ball travels, we use a ball diameter. We know how big the ball diameter is, and we simply count how many ball diameters the ball travels in a particular time. The time is measured using the frames of video. We count how many frames of video the ball advances, and each frame lasts for 1,000th of a second.